Right, here's another video from my No-frills playlist. These videos are designed to be helpful for you when you've got a last minute exam coming up. This video is to do with speed. So, not messing around, we just want to know what sort of questions come up in an exam and how do I answer them. So, we're going to be able to define the terms average speed and instantaneous speed. We want to be able to calculate the average speed of an object and to be able to rearrange and use the average speed equation and to know what relative motion is when trains and cars or whatever are passing each other. Right, so what is average speed and instantaneous speed? Well, you know that speed is a measure of how far an object moves in a given time. You'll get 1 mark for that in an exam. So this car is travelling at 60 miles an hour, which basically means it travels 60 miles every hour. All right, some people don't sort of stop and think what the units actually mean, but that's what they mean. Right, this jet is travelling at 350 meters per second, which means it travels 350 meters every second. Right, what's the difference between average and instantaneous speed? Right, average speed for 1 mark in an exam, you say it's the total distance travelled in the total time taken. And instantaneous speed is the speed of the object at a particular point or at a particular instant in a journey. All right, so 1 mark for that. How do you calculate average speed? Right, so speed is the distance over the time. So average speed, it'll be total distance divided by total time. 1 mark in an exam if they do not give you that equation. Right, distance is usually measured in meters, time is measured in seconds, so speed is in meters per second usually. Right, if you don't know how to rearrange the equation, use the magic triangle. I've got a nice video called Magic Triangle on my playlist. A magic triangle helps you to rearrange a formula. Right, so basically whatever it is that you're trying to work out, just cover it up. For example, if we want to find out what speed is, cover it up, and what you get left with is how to work it out. So that would be distance divided by time. Okay. Right, here's a quick question then. So for 2 marks in an exam, typical question. A train takes 100 seconds to travel 1,500 meters. What is the average speed of the train? So do speed equals distance over time. Bang the numbers in. Make sure you haven't got pork sausages for fingers when you're hitting the keys. And that should come out as 15 meters per second. Right, another one. A car travels at 25 meters per second, so that's the speed, for 180 seconds, so that's the time. How far does it travel this time? All right, we know that speed equals distance over time. Cover up what you're looking for, cover up distance, because we want to know how far it travels. So distance equals speed times by time. Bang the numbers in, there's your speed, there's your time, out it pops as 4,500, okay? 4,500 meters, which is 4.5 kilometers. Remember, a kilometer is 1,000 meters. Right, here's some more questions. You can have a go at that. Pause the vid, have a diggity dig. Right, there's the answers. Right, here's some more questions for you dusty utes. What I like to do, so speed equals distance over time. Get the other equations out as well. So that means that distance would equal speed times by time. And if there's a question down here to do with time, time would equal distance over speed. Right, pause the video and have a go at them. Right, there's your answers over here. Here's some more if you want to have a go. All right, so once again, speed equals distance over time. And then you'd have time equals distance over speed. And distance equals speed times by time. Get in the habit of writing them out again and again. That's how you reinforce the neural connections in your brain. You create the circuits between the brain cells. Right, there's your answers. Okay, last thing, what is relative motion? So, if you have travelled in a car on the motorway, I'm sure you have, you may have noticed that other cars passing by appear to move slowly past you, even though you know the actual speeds of the 2 cars are very high. So in other words, you might be going at 60 miles an hour and you know that they are maybe going 70 miles an hour. So you're both going fast. However, what is your relative motion compared to the other car? So here's a little table. If you've got objects moving in the same direction towards each other, so you've got one car moving like that, but you've got another car which is traveling faster and it's coming up from behind, it's eventually going to catch you, so it's moving towards you. Or if this is you here and you've got another car next to you but they're traveling faster, they're going to start moving away from you. Right, in order to calculate that, what you do is take the fastest speed and subtract the slowest speed away from it. Right, another situation is when objects are moving in opposite directions towards each other. So you're traveling that way, they're traveling that way, and you're coming towards each other. Or perhaps away from each other. So once you've gone past each other, you're traveling that way like that, and they're traveling that way like that, and you're moving away from each other rather than toward each other. Right, what you do in that situation is you add the two speeds together. I'll show you what I mean because there's some questions coming up. Right, two cars are traveling in the same direction on a road. The blue car is traveling at 25 meters per second in front of a red car which is traveling at 30 meters a second. What's their relative speed? So there's the blue car traveling like that, 25 meters a second, and you've got a red car which is behind, but it's going faster, so it's going to catch up. Okay, what you do then is you take the smallest speed away from the biggest speed. So basically this car here will be creeping up on this car at a rate of 5 meters per second. Okay, and you get 1 mark for saying that in an exam. Right, what about this? A railway line and a road are side by side. A train and a car are travelling in the same direction with the train in front of the car. The train travels at 52 meters a second and the car at 30 meters a second. What's their relative speed? Right, so here's the train track. Boom, boom, boom. There's the train there. Right, who cares? That's rubbish, but who cares? And then there's your road there. Why does the road stop? I don't know. Right, and the car is there. So the train is travelling at 52 meters per second and the car is travelling at 30 meters per second. So basically this train is going to be pulling away from the car. It's already in front and it's going to be pulling away. So the way that you work out how fast is it going to pull away, well, you just do the largest speed take away the smallest speed. So that train's going to be pulling away from the car at 22 meters per second. Okie dokie. And finally, two cars are travelling on a road in opposite directions. There's your road there. So you've got one car coming this way, one car coming this way. The blue car is travelling at 25 meters per second and the red car is travelling at 30 meters per second. I'll do the arrow a bit longer because the length of the arrow represents the size of the speed. What's their relative speed? Right, well, if they were to smash into each other, that's basically going to be like something going into a brick wall at 55 meters per second. All right, add that speed to that speed. And so you've just covered at least 11 marks worth of content. And I will kind of guarantee that speed will come up on your final exam. But if it does, you've just increased your success because you're working on your R&I, your resourcefulness and your initiative. In other words, your ability and your willingness to find things out for yourself. So well done. Work hard, be nice, and I'll see you on the next one. Bye for now.